Solving systems of nonlinear equations. Solving systems of nonlinear equations. This is an important skill. In fact, the last example we have is actually a calculus question. Yes. Okay. Now, the idea is what values of x and y work in both equations. You can do it graphically, but frankly, graphically is not going to give you a whole lot unless you do it using a computer. But if you graph it out by hand, you might get an idea of where your solutions are, how many you have, what the possibilities are. You might have no solution. Just like when you have two lines, it is entirely possible they never intersect. You might have lots of solutions, more than just two. Depends upon the types of equations you have. Graphing does a good job of showing you what's going on. Algebraically is what you want to do to solve it to make sure you're doing it. There are a few occasions where you cannot do it algebraically. I'm not going to ever give you anything where you can't do it algebraically, not here. Okay, you might need to use your calculator or use quadratic formula for one. I really don't care at this point, particularly on the notes. Okay, but you're looking at where your intersections are. Now, if I were to graph these two, the top one's a straight line. The bottom one is a parabola. Okay. For purposes here, I already graphed them, sketched them out on my notes. We'll kind of talk about that as we go along. But you have a situation something like that. I'm not completely accurate on what's going on here. But this is what I have. I've got a line, I've got a parabola. Where do they cross? They cross at two places. They cross here and they cross here. I do not know how accurate that is. I'm recording this, I am recording. Okay. But I do know they cross somewhere. I've got to figure out where they cross at. I have to find the x and y coordinates for both of those places. So I'm going to have a set of x's and y's to go together. How do I do it? I do it algebraically. Now, with systems of equations, here's the thing that's really cool. And I figured this out. This got me through an awful lot of my college physics class. As long as the number of equations is the same or more than the number of variables I have, if there are solutions, you can find them. So I have two variables, I have two equations. If there are solutions, I can find them. If I have three variables, I need three equations. If I have four variables, I need four equations. Okay, you can do systems of more. We will actually get into that more in the next chapter. Not quite as complicated as this, but it does work. The number of equations and the number of variables you have are the same. If there is a solution, you will be able to find it. I've got two variables, I've got two equations. If there are solutions, I can find them. Okay. Now, you want to do substitution on this. It's the best way on 90% of these. In fact, I think every single one of these, I do substitution. With nonlinear, substitution works the best. Okay, and I have nonlinear because I got a parabola. Parabolas are not linear equations. They're not straight lines. So the best thing to do is to actually take the top equation, rearrange it, solve it for y. So if I rearrange this, I actually add y and add 2 to both sides. I end up getting y is equal to 3x plus 2. Or, and actually that's not what I did in my notes, but it doesn't really matter. You could rearrange the second equation, actually much easier, right? Y equals 2x squared. Let's actually do that because that's easier. Doesn't really matter which one you arrange, but if I rearrange this one, I get y equals 2x squared. So I do my substitution. Take this, put it into here. 3x minus 2x squared is equal to negative 2. Now I've got a quadratic to solve. Set it equal to 0. If you can, you always factor. Factoring is the easy way to do them. -4, -3. Two numbers that multiply to give me -4, then add to give me -3. 1 and -4. Divide them both by 2. So I end up getting 0 equals 2x plus 1 and x minus 2. So I get x equals 2 and x equals -1/2. But what else do I need? I need my y's. I need the y's that go with my x's. And that's easy enough to do. What do you do? Just take those two numbers, plug them back into either equation. Really doesn't matter. I think this one here that I rearranged is perfectly fine. Why not? I already get y equals, right? Just plug in 2, plug in 1/2 into that, or -1/2 into that. Either one, it doesn't, I've got to plug them both in and figure it out. But it doesn't matter which equation I put them into. So why not use this one that's already solved for y? So when x equals 2, y equals 2 times 2 squared. So y equals 8 for here. And when x equals -1/2, y equals 2 times -1/2 squared. -1/2 squared is 1/4 times 2. I end up getting y equals 1/2. So I have the points 2, 8, and -1/2, +1/2. Okay, questions? Fairly straightforward. Okay, what's my top equation? What does it graph out to be? A circle, right? The radius of the square root of 13, and square root of 13 is between 3 and 4, somewhere in there. So it's centered on the origin. Close enough for what we're doing in here. And the other one is a parabola. Y equals x squared minus 7. It opens up, but it's moved 7 units down, so the vertex is down here. And it goes like this. Which means if my graph is accurate, how many solutions do we have? 4. Okay? That's what we're looking for. If my graph is accurate, we've got 4 solutions. Now, rearrange one of them to get the other. I'm going to tell you, it doesn't really matter, but I don't want to have 2 sets of squares. If I do the substitution as it stands now, and I can, because I know what y is, right? Do not write this down. I would have x squared plus x squared minus 7 squared is equal to 13. Which means I'm going to have an x to the 4th in there, right? You don't want to deal with an x to the 4th if you don't have to, do you? However, and I could, it would work. It actually really wouldn't be that bad. It wouldn't be that great either, but it wouldn't be that bad. But what you really want to do is if I take this, rearrange it for x squared, to give me x squared equals y plus 7. Take this and put it in for that. Things you learn after doing it an awful lot. Part of my job is to teach you, hey, do this instead of that. Will it work the other way? Yeah, it'll work the other way. This is a lot easier. Okay? So I get y plus 7 plus y squared is equal to 13. Rearrange it, set it equal to 0. 0 equals y squared plus y minus 6. Zero equals y plus 3, y minus 2. So I end up with y equals 2. Sorry, y equals 2, y equals negative 3. And that kind of sort of lines up with what I've got going on here. Actually, ooh, that's not too bad, is it? For what I got lined up. I have, here's one y. The other y is actually down here. It makes sense. Looks like I'm going to have 4 solutions. So I have 2 y's. For each of those 2 y's, I'm going to have 2 x's. Okay. So what I do is I just want to take 2 and put it into, might as well do it into that one. So for this one here, I've got x squared equals 2 plus 7. X squared equals 9, x equals plus or minus 3. So for y equals 2, I get 3 and minus 3. So I have the point 3, 2, and the point negative 3, 2. When y is 2, I have plus or minus 3 on my x's. Do the same thing for the other one. Take negative 3 and plug it in there. X squared equals negative 3 plus 7. X squared is equal to 4. X equals plus or minus 2. So when y is negative 3, x is plus and minus 2. So I get 2, negative 3, and negative 2, negative 3. And these are my 4 points of intersection. A regular over in the brown box. Okay? Sometimes you may have a lot of intersections, sometimes you're not. Questions? Okay. Bottom equation, that's easy, right? What does the bottom equation graph out to be? The line. X-intercept, X and Y intercepts are 8 on this one. So that's kind of off. The intercepts are off. The whole graph is just kind of over here somewhere. I'm not going to worry about that right now. What about the top one? Does anybody know what that looks like? Nope. What? Almost. No. She's closer. It's a semicircle. It's a semicircle. 36 is my r squared. What I have here is I have y equals the square root of r squared minus x squared. If you square both sides and move the x squared over, you get x squared plus y squared equals r squared. You get a circle. This is a semicircle. This is the top half of the circle. If I wanted the bottom half of the circle, I would have to put a minus in front of it, and that would give me the bottom half of my circle. Okay, a little bit of calculator history. About almost 30 years ago, your graphing calculators, in order to graph a circle, you had to be smart enough to have it graph the top half and then have it graph the bottom half. It would not graph the entire circle in one shot. You had to be able to rearrange it, type in, if I want a circle, I got to do this half, I got to do that half, and it would draw the top, and then you would do another equation to draw the bottom. It would not draw a circle all in one shot because it couldn't do conic sections. It could not do y squared. Really sucks. So this is what you have here. That's what you have. That's what that top one is. And then you've got a line going there. Now, I'm not sure how accurate my line is. Does it cross? Does it touch? Does it miss? How many solutions could I have? At the most, I could have two, because at the most, I could have what I have here and cross it. I could have none. I could also have one solution, right? If the line is tangent to the curve, but the line touches in one place, I might have one solution. I might have none if it doesn't intersect at all. I might have two, which would be represented by what I have here. I'm not being entirely accurate in my graphing because I want to rely more on the algebra. But I do want you to understand, hey, that first one is the semicircle. You're actually going to see that equation several times in your calculus textbook if you're taking it here next year. Now, this is an easy one to set up. I have y equals something and y equals something. If y equals two somethings, those two somethings are equal. The transitive property. If y equals a and y equals b, then b equals. If y equals b and b equals and y equals c, then b equals c. Transitive property, right? Square root of 36 minus x squared equals 8 minus x. Yeah. What do you think my first step is going to be to solve this? Square both sides. Get rid of the square root. Dear Lord, get rid of the square root. Square both sides, but remember, it's 8 minus x quantity squared. It's not 64 minus x squared, right? So on this side, I get 36 minus x squared. This side, I get 64 minus 16x plus x squared. Right? Because you got to square it out. Got to get your middle term. Set it equal to 0. You want positive x squared. So I would add x squared and subtract 36 from both sides. You get 0 equals 2x squared minus 16x plus 28. Is this factorable? I don't know. Well, it is from the standpoint of everything's divisible by what? 2. Simplify it first. Divide everything by 2, including the 0. What is 0 divided by 2? 0. 0 equals x squared minus 8x plus 14. Are there two numbers that add to give me 14? Or sorry, multiply to give me 14 that add to give me 8? No, so it's not factorable per se, which means you would do what? Quadratic formula. I'll save you the hassle.
Yes.
You get x equals 5.414 and x equals 2.586. And by the way, your graphing calculators will also solve that for you. Without using the quadratic formula, there's ways to do that. I know on the Casio, I know how to do it really slickly. I'm not sure how to do it on the TIs, but the TIs is pretty slick too. You should know how to do that, even though you may not be able to do that on a test per se. You should still know how to use your tools in front of you, using your graphing calculators to do that. I know I do it to check my work, even if I do it by hand. So what do I do to find y? Plug those into either equation. Which equation would you want to do?
The top one.
Yeah, you might. No, I'm doing the bottom one. Put them into here. Put them into something easy. Take 8 minus each one of those numbers to find your y's. When x is 5.414, you get 2.586. And when x is 2.586, you get y equals 5.414. It is not always symmetric like that. It is in this case. When x is one number, y is the other. When y is one number, the x is the other. It doesn't always happen that way. Questions? And you can easily rewrite it in coordinate form if you want to do that. I'm not going to worry about it here.
Wow.
Okay, give this one a try. I've done enough of them. Your turn. All right. Okay.
Oh, wait, it did have two.
So, easy substitution. X squared equals y. Take x squared, replace with y. Y minus y squared is equal to 4. 0 equals y squared minus y plus 4. It's not factorable. And if you put it into your calculator or try to do the quadratic formula, it doesn't work either. Remember our good friend, the discriminant? B squared minus 4ac. So negative 1 squared minus 4 times 1 times 4 gives me negative 15, which means I have no real solution. Remember that? That's the part underneath the radical of the quadratic formula. If that comes out negative, you got no real solutions. So that means there is no real solutions. There are no solutions. These two never cross. What is the top equation going to graph out to be? Hyperbola, right? X squared minus y squared. Divide everything by 4. Your a and your b are both 4, which means that a squared and b squared are both 4, so a and b are both 2. So it looks something like this. And then you've got a parabola in the middle. And they never touch. No intersections. That happens. What? X squared comes first, so it opens sideways. If it was y squared, then yeah, we'd have solutions.
Here's a calculus problem.
All right, yeah. So if you were having me next year for calculus, this would be a test question on your last chapter test before studying for the AP exam. This is a question I have on one of my tests that I've done several times. Find the area between the two curves. This is what the question is asking you to do. Just so you're aware of this, as you're trying to find this area here. What is that area? You can actually find it very easily using calculus. You do not yet possess the skills to do that, which is okay. However, you do possess the skills to find the first step, which in order to find that area, you need to find out where the points of intersections are. You don't know those points of intersections. You do not know your boundaries for your areas. You can't calculate it if you don't have the boundaries. You have to find the boundaries first. So your first step is doing what we do. And this one's an easy one. X equals something, X equals something. Those two somethings are equal to each other. Y squared minus 4y plus 10 is equal to negative y squared plus 9y minus 5. Move everything over to one side, and you want your squares to be positive and set it equal to 0. 2y squared minus 13y plus 15 is equal to 0. This is factorable, where you can use your calculator or whatever. I'm not going to worry about doing that step on this one here. You do end up getting 2 points of intersection for your y. You get y equals 5, and y equals 1.5, which is 3/2, right? So I know my y coordinates. I got one y coordinate here, and I got one y coordinate here. Do not, and I've had students that have done this in the past in calculus, and it's driving me nuts. Do not ever assume that the intersections line up exactly where they look like they line up according to the graph. They do try to make the graphs accurate, but you have to be absolutely dead on positive where they are. Oh, it looks like it lines up with 6, or it looks like it lines up over 5, or something like that. You can never make that assumption. You absolutely cannot use the graph for the coordinates unless you know for sure and for certain. If they give you everything you need, it's not a big deal. Ones like this, you cannot assume X and Y coordinates from the X and Y grids. They will be in the general area where they're supposed to be. If they want you to know exactly where they are from that, they will let you know exactly where they are from that. Okay, do not ever make assumptions about things like that. Do not make assumptions about right angles unless you know for sure. Okay, they will tell you what you need to know along those lines. So I found my y's. I need to find my x's as well, although technically to solve this problem you only need the y's. If you're doing calculus, the y's are what you need. To find the x's, what do? You plug 5 and 1.5 into either equation. I did the one on top because it starts with a positive y squared. It's a little easier. Doesn't really matter. When y is 5, x is 15. When y is 1.5, x is 6.25. Sorry, 6.25. Now, for snorts and giggles, because you cannot do this yet, your step for solving this, no, I don't have a solution because I haven't worked it out. I don't remember what it is. The area between the curves. What you do is it's an integral. It's an integrand. Well, that's the second half of calculus. You don't get that until like the third from the last chapter is when you get your integrand sign. In this case, we're going to do it in terms of y. Let me explain. If I do this in terms of x, I've got a little problem right here where the same curve provides the top and bottom of my area. I can never have that be where the same curve is the top and bottom. I also have the same thing kind of going on right over here on the edge. The same equation provides the top and bottom of my area. So I have to do it in terms of y because that's the only way I have two curves that are separate. Which one is, if I'm looking at it sideways, which one is the farthest away from the y-axis? Which one's the one on top? It would be the negative y squared, right? The one curving this direction is negative y squared. So that's my top equation. So I would have that equation first, negative y squared plus 9y minus 5, minus the bottom equation, which in this case is the one opening away from the y-axis, which would be y squared minus 4y plus 10. And then we're doing it in terms of y, so we have dy. And you'll learn all this stuff when you get to calculus. And what we found was our bounds from 1.5 to 5. We're going from here to here. We're only calculating the area between those two curves from one place to the other place. Now here's a really cool thing. What you're doing, I'll explain it to you now. What you're technically doing is you're taking this space and you're dividing it into rectangles. And you're adding those rectangles together.
That's a lot of rectangles.
Technically, you're adding together an infinite number of very skinny rectangles. You are going to take and add an infinite number of items together and get a singular value. That's what you do. Because the idea, what an integral is adding in those little spaces, but technically the definition of an integral is you're adding together where the largest one is getting close to 0 in size. So if the largest one gets skinnier and skinnier, what happens to the rest of them? They also have to get skinnier, which means you're adding more and more rectangles, so technically you have an infinite number of rectangles you're adding together. So you get a singular value.
Word rectangle.
Yes, you can. You can do this by hand. You can also do this on your calculator. very quickly and you get the actual numerical value of that area. By the time you're doing this in class, if it were my class, you would be allowed to use your calculator to solve this. But on the answer key, I've also done it by hand. Because you can do this one by hand. It's not that hard. It looks nasty. It really isn't that hard by the time you get there. It's not hard. Okay?